Alright, now on to hydrobromic acid. So I set up this formula right here. Now go ahead and pause the video, try to set it up, figure it out, solve for the H3O plus concentration and find the pH, and then come back and see if you did it right. Okay, so that was kind of a trick question if you did actually pause it. If not, I probably sound stupid, but this is actually not the equation that we are going to use. It's the right equation for a non-dilute solution of hydrobromic acid. But remember when we said earlier that if this is anywhere near the concentration of an acid, we're typically going to always use strong acid. If it's anywhere near 1 times 10 to the negative second, or the square root of the Kw value of 1 times 10 to the negative 14th, it's anywhere near 1 times 10 to the negative 7th, we are going to consider the autoionization of water, or we're going to consider how much water is already acidic, which is the H3O plus product of water's ionization, autoionization. And so we are actually going to erase this, and just drop this down one, draw a line through this. So anytime we consider the autoionization of water, we're just going to use water as our equation. And what we do is we take this, remember this, this is like the main difference. We take this and we consider it the initial concentration of our hydronium ion concentration. And what I mean by that is we consider this value the same as, like, we put it in the I category for initial under H3O plus as the product. We're saying we're already starting this reaction with this much acid. Now let's see how much more acid is produced after water autoionizes. So we know that we aren't going to be writing anything for a pure liquid. Now we are going to add 2 times 10 to the negative 7th molar, and we are going to have 0 hydroxide concentration because we're just, all we are is HBr, and the product that does not make hydroxide, it makes Br minus, but we aren't going to be considering that right now. So we take this value and put it right here. And just like any other rice table problem, we know that after H2O reacts with H2O, we are going to get x plus x plus x. At equilibrium, we get 2 times 10 to the negative 7th plus x and x. And now the other part of this is when we use the autoionization of water, like we also said earlier, is we're going to use the Ka value, or the Kw value, which is the Ka value of water. So remember, Kw equals 1 times 10 to the negative 14th. And I'm just going to bring it down here. So 1 times 10 to the negative 14th equals 2 times 10 to the negative 7th plus x times x. Now, just don't mess this up. These are both products, so you're not putting one over the other, they're multiplied by each other, right? Now, what we're going to do is we'll solve for x if we can, but right now you should already know that we're not going to be able to solve for x directly, and we're going to have to use the quadratic formula. If you aren't able to figure that out right now, just try solving it and you'll get stuck. So what do we do right now? We multiply, right, do the FOIL thing. So we're going to get 1 times 10 to the negative 14 equals, I'm going to put x squared first because I know that's how I'm going to want to set up my quadratic formula. It doesn't matter if you do or not. Alright, and so we get this bottom equation, and now we're going to have to put everything on one side and make it equal to 0, right? So all we're going to do is bring this over by subtracting it, because technically there's a positive sign right there, and we get 0 equals x squared plus 2 times 10 to the negative 7th x minus 1 times 10 to the negative 14th. And now remember, this is going to be your a, which is 1, b, which is 2, c, which is negative 1 times 10 to the negative 14th, not positive, okay? And now for x, go ahead and pause it and put it in and make sure you can do it right, because I normally calculate them out anyways if you get the answer wrong to see where you did it wrong, but it saves me a whole ton of time if you just get it right. So I'd rather you guys just get it right. But you should get negative 2.41 times 10 to the negative 7th, or 4.142 times 10 to the negative 8th. Now you know that this negative value isn't going to be accurate, because we can't get a negative concentration. We get to 0 and we run out, right? So we're going to take that up here, and that's going to be our acid concentration. So just remember, we have the concentration from the HBr, the very dilute HBr, plus the autoionization of water. And that's going to be our total acid concentration. So you should add those together. So 2 times 10 to the negative 7th plus 4.142 times 10 to the negative 8th. Put brackets around it if you want. What is that going to give us? That should give us 2.414 times 10 to the negative 7th. And that equals, right, the H plus concentration. And so to get the pH, we take the negative log of this, and that should give you 6.17 pH. Now, in order to answer this question correctly, now this is easy, but I just set it up this way so that you would have to, so that you could see two rice table problems. You're just gonna, find the difference between the pHs. You're just gonna, take your 6.17 pH minus 1.29 pH, and that should equal 5.33 pH. And then always don't, obviously remember, don't forget sig figs, which is actually going to be 1 sig fig. So you'd get about 5 pH difference. But let's just look at this for a second. Does this make sense? We took very, very, very little amount of a strong acid. We could almost say, just very little strong amount of a strong acid, and it brought down the pH almost by an entire, log, whatever that is, log of 1, or 1 pH level. And then we added a ton more, like what, a million times more, times the amount of weak acid, and it brought it down all the way to 1.29 pH. Now these should both be acidic. If for some reason it went up, or like this was hardly, now if you added a very, very, very weak acid, it could be a lot higher than this, like 3 or 4 if it was extremely weak. But 5.4 times 10 to the negative second, it's a weak acid, but it's not that weak compared to some of like these other acids, methanoic acid or carbonic acid, and then just keep on going down. Those are going to change the pH less and less from 7. So just make sure your answer makes sense, and email me if you have any other questions.